we'll start with minus 3. Square root of 2 times minus 3 plus 7 minus quantity 2 is the square root of 1 minus 2, which is, well, minus 1. And that is not equal to minus 3. So, nope. Not going to do it. Not going to work. We can... All right, that one's out. Hopefully the other one works. Let's find out. So square root of 2 times 1 plus 7 minus 2. That's the square root of 9 minus 2, which is 3 minus 2, which is 1, which of course equals 1. So in fact, our solution, just x equal to 1. That's it. So once you get the hang of these, they're all kind of similar. This one's a little bit different, though, honestly. I think in some sense this next one's easier than the one we just did, like exercise 25. Probably a little bit easier. Because this one won't land us to a quadratic we have to solve. Here's 25. We're supposed to solve the square root of 7y plus 8 equals to the square root of 6y plus 12. Mm-hmm. Right, yeah, I mean, just right, so squaring. And so that gives me, what do you say? That's 7y minus 6y is 12 minus 8. But that gives me y equal to 4, yeah. And we can check that, right? 7 times 4 plus 8 is the square root of 36. And the square root of 6 times, did I say 36? Is that right? 6 times 4 plus 12 is 24 plus 12, which is also square root of 36. So they both work out to 6. 6 equals 6. Any questions? All right. So since we have a minute or two left, show you something, or show you something that. I mean, one curiosity you might have, if you start thinking about stuff, is, well, why don't we do more with cube roots for one thing? You could solve something like x equals to the cube root of x minus 1. You could work this example out. It wouldn't be that bad. Just what do? You cube both sides. What's the cube of the cube root? Well, it's whatever's inside. It's just x minus 1 again. But so one of the reasons we don't typically ask questions like that too much is after you do that, then what do you got to do? What are you facing? You're facing x cubed minus x plus 1, right? And how do you solve that? Well, it's just not nice. There's no, if you just write down an arbitrary cubic, there's really no guarantee it's going to be anything that's very nice to do. So that's one of the reasons we don't do these kind of problems that much, is because they're kind of dangerous in that sense. And we can confuse the students enough just using square roots, right? The other thing you might wonder is, like, why don't we ask questions like this? I mean, what if you had the cube root of 7 and you wanted to rationalize this denominator? How would that work? I mean, could we just do like 2 minus the cube root? You know? You could try that. What would happen? So what would happen is, yeah, you'd cancel out the cube root of 7, right? But what would that do? You get a 4, right? And these terms, these cross terms cancel. But then what's the cube root of 7 times the cube root of 7? You look at it a couple different ways. One thing is it's the cube root of 49. Another way to look at it would be it's the cube root of 7 squared, But the larger point here is you haven't removed the radical, have you? So how do you remove radicals if it's like a cubic or a higher root? Like, is there a way? There's not an easy way. I'll just say that. But this is something that you can learn how to do with abstract algebra. Like, there are techniques. It has something to do with what is called the Galois group of the polynomial, and there's things called Galois conjugates, and you can sort of build a strategy for removing radicals in the denominator, but it's much, much more complicated for third and higher order radicals. So we just do square roots, because that we can do. It's not bad. Anyway, I should now tell you at least one problem that will for certain be on the final once I turn this camera off.